to talk about when we solve quadratic equations, what those two answers actually mean and where they show up on the graph. And we can do this on our graphing calculator. So if we're doing it on our graphing calculators, you want to, I guess, like type in the equation under y equals, which is at the very top. So we do y equals whatever the equation is. And then we're going to graph it. You choose the second key and graph. And then when you do that, you'll see this picture. If you don't see that picture, you can always go to Zoom Standard, or Zoom Decimal. They will help you see it. And then we're going to find the roots. And the roots are going to be here and here. And the roots are the same questions, or the same solutions that we get by graphing. So let me explain that difference between equals to y and equals to 0. So initially this equation could be y equals x squared plus 5x plus 6. And there would be an infinite number of solutions to that equation. But if I take out the y and replace it with the 0, now I'm finding just the roots. Because the roots are where the graph crosses the x-axis, and the y-coordinate on the x-axis is 0. So that's why we replace the y with the 0. If we're graphing on our calculator, it's going to be y equals. It's going to show us all the solutions. But when we're solving it by hand, it's going to give us just the roots, -3 and -2. And those are going to be the 2 points, the 2 x-intercepts where the graph crosses the x-axis. And then my graph, I can tell by my calculator, looks something like this. Now this point down here is going to be the next question that people say, well, how do I know where the vertex is? How do I know how far down to go? We're actually going to talk about that later in the chapter. So for right now, our graphs are just going to be a sketch, so you can kind of sketch where it looks like the vertex is, and then as we get later in the chapter, we're going to spend a long time talking about that vertex. But for right now, we're just getting that idea of the roots. Okay, and so the roots happen when we set our equation equal to 0, and we factor x plus 5, x plus 4 equals 0. And you can jump ahead and be like, oh, okay, I know the roots are going to be x equals -5 and x equals -4. That's not an ordered pair. It's the ordered pair -5, 0, the ordered pair -4, 0. Right? And all our quadratics here are going to open up. I'm actually doing this here without a calculator, so I might have my vertex. You might be able to get a better idea of the vertex by looking at your calculator here. I'm just getting that this is 3 and -2. So 3 and -2. Here, if I factor this, I can factor out an x. X plus 4 equals 0, so I get the roots are 0 and -4. Moving on here, 2x squared minus x minus 3. It's a little bit harder to factor, 2x and x. -3 and +1. So I'm going to get the roots of 3/2 or 1.5. I can just estimate that, and -1. Now this one's interesting because x plus 4, x squared plus 4, x plus 4 is x plus 2, x plus 2. It has what we call a double root. You definitely need to write that twice, that double root. And that double root is going to do what we say, bounce. Double roots bounce off the x-axis. They just touch it at that one point and then up. Yikes, I don't have my graphing calculator with me. I got to come back and do number 6. But I'll show you how we're going to do it on the calculator. When they can't be factored, right? So that's going to have 1 negative, 1 positive. I'm just going to like estimate that. It's not right. But the two roots here, if you type in y equals x squared minus x plus 5, it'll give you the whole graph, right? And we're going to do something called second calc 0. So on your calculator, you do second calc 0. and then left, right, enter, left, right, enter. So you're going to hit L and R over here and L and R. Left bound enter, right bound enter, and then guess enter, and then it's going to give you the decimal for the first root. Similarly over here, you swing your ordered pair back, second calc 0, choose any point below the x-axis, any point above the x-axis, enter for a guess, and it'll give you that ordered pair, and we're going to round the zeros to the nearest hundredth. I'll show that again in another video. That's just the basics. Another thing that's pretty fundamental is now we've got like 3 cases. I'm actually making an assumption on number 6 that it crosses at 2 points. Now that I'm thinking about it, number 6 might be a third possibility here. I'll make that a little bit more clear, like floating. So most of what happens is you get 2 real roots where it crosses the x-axis twice. Sometimes, like in number 5, you get what's called a double root. It's still 2 roots, it's just the same root twice. Sometimes, and I'm wondering if that did happen in number 6, where it just floats. And if you have one that just floats, this has no real roots. But as we will learn, it has 2 imaginary roots. What? 2 imaginary roots. Or sometimes I'll say 2 complex roots. It's the same thing. So again, that's going to be made more clear. Number 6 might have been one of those. But sometimes we're also going to do ones like that where we have to find the decimals on the calculator. So this is graphing quadratic equations.